All right, everybody, we're going to do a pKa question from Fall 21, Test 1, Part 4. First question in the short answer. It should look familiar. We did questions like this way back in Orgo 1. We got some hints here. We're supposed to fill in the missing piece. We're asked about pKas. I hope that triggers that it's acid-base chemistry, everybody. That's good. And I hope you remember that in chapter 16, we learned about this new H called an alpha H. There's alpha H's here. There's two of them. I'm only going to show one. And both of those have pKa equals 20. I suspect one will lead to the major product and the other will to the minor. I hope that's not a revelation to everybody. Major or minor. You better have some kind of choice of which H to take, right? And we do. And the hint, I think we need to look at very carefully. The bulky isopropyl groups, that's these here, in case you haven't seen that. IPR is isopropyl. Nobody's going to put their hands up during the exam and ask me what IPR is, are they? Because it's not on the periodic table. They say, oh, I see PR in the periodic table. Please don't do that to me. Don't. This is not praseodymium isopropyl. These bulky groups slow down the approach of the base to hydrogens that are on the bulkier carbon. Oh my God, couldn't I just put a big fat arrow and saying the bulky isopropyls slow down the approach of the base to this hydrogen? Isn't that the bulkier carbon that's attached to that? So are you going to pick that for major? When I told you it's slow? Please don't pick that for major. That's going to be minor. Okay. And we're going to put the minor here. And ladies and gentlemen, we're supposed to know that if you take an H plus off of a molecule, you end up with a minus. There you go. And I gained a carbon. Don't do that. There we go. So we got our 4 points for fill in the missing pieces. Draw a more stable resonance form for the missing piece. I mean, I could show you the mechanism, but if that's a minus, isn't there a lone pair there? Can't the lone pair resonate towards the carbonyl? Resonance. And the pi breaks and becomes a O minus. Oh, I like O minus compared to C minus. I hope you do too. O minus, double bond. And over here, we're going to see an O minus. It's actually better than the O minus above it. What? How can this be minor? Isn't this a better double bond than this? It is. It is. So why did we make this the minor product? Because you were told to. Sometimes you don't know enough yet. You better look at the hints. And this is that discussion I said would continue later. This is not the later. I'll just remind you that there's two things that govern a lot of chemistry. Some things are equilibrium, and we call those thermodynamic things. And the others are this approach, which are called kinetic things. If it's easier to get to something, you're going to get there faster. Kinetics and thermodynamics often go in opposite directions. Here, you didn't even need to know that because I told you just do what I said, right? Okay, so we got a lot of points. More stable, done. pKa's, we did the one acid here. What about this acid here? That's an H on a neutral nitrogen. What you got for that pKa? Well, don't be shy. They're shy today. An amine, pKa is 40. Now you can do pKeq. Okay, EQ. 20 minus 40 negative. Sorry, sometimes I got carried away with the colors. There you go. And then KEQ 10 to the 20. Save. Oh, that's big time. Big time. Circle the arrow going to the right. We knew that before we even did the math, right? 40 is a lot more stable than 20. Equilibrium favors the 40. So in terms of acid base, equilibrium favors this one. I think we're done. Didn't ask for pKb's. I could have. I didn't. Probably won't on Monday either. But if you're curious, how would I do the pKb for this base?
14 minus 40.
Yeah, he nailed it. He said 14 minus 40, which is the pKa of its conjugate partner. And that ends this segment here. And off we go.